You is how we simplify terms like you see here with negative powers. And what we're going to do is use one or more of these rules that you see up here. Well, let's start by looking first of all at 5x to the power minus 1. This is 5 times x to the power minus 1, so we can think of this as 5 times x to the minus 1. But what is x to the minus 1? We can use this rule here. X to the minus 1 would be 1 over x to the power 1. The n would be the 1. So 1 over x to the power 1. So we've got to multiply essentially two fractions together. Remember, this is 5 over 1. So if we do that, what we've got is 5 times 1, which is 5, all divided by 1 times an x to the 1, well, just simply x. So if this was, say, 5x to the minus 2, it would end up being 5 times 1 over x squared, which would be 5 over x squared, and so on. And with a bit of practice, you should be able to go from there to there. Let's have a look at this next one. In this one, I've introduced a number in the denominator, but it's still much the same kind of thing as we've just done here. Think of this, we've got 3x to the power minus 2 all over 4, but think of it as 3/4 times x to the minus 2. And x to the minus 2, using this rule, would be 1 over x squared. And then put this together by multiplying the two fractions together. You've got 3 times 1, which is 3, all divided by 4 times x squared, which is 4x squared. So if you had, say, 3x to the minus 5 over 4, same kind of thing, 3/4 times 1 over x to the power 5, giving 3 over 4x to the power 5. And again, you should be able to go from here with practice straight down to here. Right, now in this next example, what I'm trying to show you here is how we handle fractional powers that are negative. And I'm going to do the same thing again down here with a number in the denominator. So we must think of this one as 5 times x to the minus half. So we've got 5 times, but we know that x to the minus a half, using this rule here, will be 1 over x to the half. So we've got 1 over x to the power half. Multiply the fractions together, just like we did over here, and you're going to end up with 5 over x to the power half. But in this example, we've got the fractional power, x to the power half. So we can simplify it further, if we wish, by using this rule. X to the power 1 over n is the nth root of x. So n is 2, so this is going to be 5 over the second root of x, or as we often call, just the square root of x. You don't need to write that 2 in. So we have 5 over root x. If we had 5x to the power minus a third, then that's going to be 5 over the cube root of x. 5x to the minus a quarter would be 5 over the fourth root of x, and so on. So I hope you're getting the idea for these. Right, well, in this next example, as I said earlier, I'm introducing a number in the denominator here. This one, we've got 7 over 2 being multiplied by x to the minus a third, which we know is times 1 over x to the power third if we use this rule here, the negative power rule. Multiply the fractions together, and what you've got is 7 times 1 is 7, all divided by 2x to the power third. But the x to the power third, by this rule, is the cube root of x. So we've got, essentially, when tidied up, 7 all divided by 2 times the cube root, little 3 there, of x. 7 over 2 times cube root of x. Now in this next example, you'll notice that I haven't got a third anymore, I've got 2/3. We've got 8x to the power minus 2/3. So what's this going to be? Well, 8 times x to the power minus 2/3. Using the negative rule, that's going to be times 1 over x to the power 2/3. But in this example, what we do is we can multiply this together, 8 times 1, 8, all over x to the power 2/3. But we now use either this top rule here or this bottom rule here when you've got a fraction, m over n. We've got our m over n, m being 2, n being 3. Now for something like this, I'm going to use the bottom rule. What that is that x to the power m over n is x to the power m to the power 1 over n. In other words, the nth root of x to the power m. So translating that across here, we've got essentially the cube root, because of the 3's in the denominator, the cube root of x squared. That's using that bottom line. You don't have to use that line. You could use the top line and you would get 8 over, and all we do is we cube root the x, and then square the result afterwards. But in this particular scenario, I think personally that looks the neatest version compared to that, but both give the same answer. In this one, all I'm doing now is again introducing a number in the denominator. So it's going to be very similar to this, but only we're going to have a 7 there in the denominator. Again, I'll show you. This is 5/7. Oh, by the way, you don't necessarily have to have this as 5/7 x to the minus 3/4. You could have easily been given this sum as 5x to the minus 3/4 all over 7. But whatever, we think of this as 5/7 times x to the minus 3/4, so that's 1 over x to the power 3/4. Multiply the fractions together and you end up with 5 times the 1 is 5 all over 7 times x to the power 3/4. Use this rule again and you end up with 5 over 7. Then we take the 4th root of x cubed. There you go. Or if you don't want that version, then what you can do is write this as 5 all divided by, and then you can say 7 and then just do the 4th root of x and then cube that answer there. Alright? So I hope you can use these examples to simplify anything that is similar to these by following these methods. And that brings us now to the end of this tutorial.